We'll start in 1 minute. Today we'll go over the final exam review, and the final exam is tomorrow from 11 o'clock a.m. to 12:40 p.m. I'll send a Zoom schedule for the proctoring tomorrow. Okay, a problem from section 10.5, convert the complex number from rectangular form to polar form. Okay, so the value of r is the square root of 1 squared plus the square root of 3 squared, which is the square root of 1 plus 3, or the square root of 4, which is 2. Z is in the first quadrant. So tangent of theta is the square root of 3 over 1, or the square root of 3. So theta is the inverse tangent of the square root of 3, and that is pi over 3. So in polar form, z is 2 times the quantity cosine of pi over 3 plus I times the sine of pi over 3. You can always verify that this is correct by working in reverse, by converting from polar form back to rectangular form. Okay, the next problem, convert the complex number from polar form to rectangular form. So here, multiply the square root of 2. We know how to evaluate cosine of pi over 4. Cosine of 45 degrees is the square root of 2 over 2. And sine of pi over 4 is also the square root of 2 over 2. And then distribute multiplication by the square root of 2. We get 2 over 2, or just 1, plus I times 1 is just I. So 1 plus I is the rectangular form for that complex number. The next problem, compute the quantity in brackets is 3 times the quantity of cosine of 15 degrees plus I times sine of 15 degrees, all raised to the power 4. So we can write this as 3 to the 4th times the quantity cosine of 4 times 15 degrees plus I times sine of 4 times 15 degrees. 3 to the 4th is 81. So 81 times the quantity cosine of 60 degrees plus I times sine of 60 degrees. And we can go further because we know those values. Cosine of 60 degrees is 1/2. The sine of 60 degrees is the square root of 3/2, and we multiply that by I. So we'll take it one step further, distribute multiplication by 81. So we get 81 halves for the real part, plus 81 times the square root of 3/2 times I. In addition to this final exam review sheet, you can also review the tests that you've taken, tests 1, 2, and 3, and the answers, and also the other test review sheets that we've already gone over. Okay, the next page. From 10.6, section 10.6, number 1, eliminate the parameter t and write the parametric equations as a Cartesian equation. So in this case, you can solve either equation for t. I'll solve x equals 5 minus t for t. So if I add t to both sides and subtract x, I get t equals 5 minus x. And then in the other equation, y equals 8 minus 2t, replace t with 5 minus x. Do the algebra and arithmetic. We get y equals 8 minus 10 plus 2x. And finally, we get y equals 2x minus 2. There is the equation in Cartesian, the Cartesian equation. Okay, the other example, if x equals 4 times the base 10 log of t and y equals 3 plus 2t, we can solve either equation for t, it doesn't matter. If we solve the x equals 4 times log of t for t, first divide both sides by 4. So x over 4 equals the base 10 log of t, and then convert this logarithmic equation to its exponential equation equivalent. The base 10 raised to the exponent x over 4, that's equal to t. And then in the other equation, replace t with 10 raised to the x over 4. Okay, make sure that you realize you cannot combine the factor 2 with the base number 10. You have to write it as 2 times 10 raised to the exponent x over 4, because the exponent x over 4 applies to the base number 10 only. It does not apply to the factor 2. Okay, number 2, parameterize the line segment from the ordered pair 4, 1 to the ordered pair 6, -2, so that the line is at 4, 1 at t equals 0 and at 6, -2 at t equals 1. Okay, so the ordered pair 4, 1, we're going to multiply each of the coordinates by 1 minus t, and then we'll add that to the other ordered pair 6, -2 multiplied by the parameter t. So this is our x xy coordinates. Okay, then we can write this 4 times the quantity 1 minus t. So the x coordinate here is 4 minus 4t. And the y coordinate 1 times 1 minus t is 1 minus t. And then the ordered pair 6, negative 2, multiply each of the coordinates by t. So we get 6t and negative 2t. Okay, then one more step. Add the x coordinates. 4 minus 4t plus 6t is 4 plus 2t. Then add the y coordinates. 1 minus t plus negative 2t is 1 minus 3t. If you write the parametric equations equivalent or separately, you can do that. If you write x is 4 plus 2t and y is 1 minus 3t. And this is for values of t between 0 and 1. Okay, in the next part, we will rewrite the parametric equations as a Cartesian equation by constructing an xy table. Okay, so we'll pick t values and use the t values that we pick to find the corresponding x and y values. And then we will investigate the x and y coordinates and use those to come up with a Cartesian equation. So I could pick t to be anything I want, but I'm going to start with t equals 2 and then increase t values. I think those 4 t values, that's good enough to start with. So when t is 2, x is 4 minus 2 or 2, and y is 3 times 2, which is 6. 6 plus 2 is 8. When t is 3, 4 minus 3 is 1. And the y coordinate, 3 times 3 plus 2 is 11. When t is 4, x is 4 minus 4 or 0. And the y value is 3 times 4 plus 2. 12 plus 2 is 14. And we'll just do one more value for t. If t is 5, the x coordinate 4 minus 5 is negative 1. And the y value, 3 times 5 plus 2 is 17. So notice we can identify the coordinates x and y as having a linear relationship. So that means y is a linear function of x. So another thing to notice, we have the y-intercept when x is equal to 0. The y-coordinate is 14. So we have an equation of this form, y equals mx plus b. And when x is 0, the value of b is 14. And we can also observe what the slope is. So notice if we begin at 0, 14, if we increase the x value by 1, the y value decreases by 3. So it appears that the slope is negative 3. So we can at least write that down, and we can test it to make sure that we have the right equation. So y equals negative 3x plus 14. Another thing you could do, you could pick two ordered pairs and use the slope formula and verify that, yeah, sure enough, the slope is negative 3. But if you test a couple of points, when x is 1, the y-coordinate is negative 3 times 1 plus 14, which is 11. And it's obvious that when x is 0, the y-coordinate is 14. So it appears to work out. So if the instructions didn't say to use an xy table to find the Cartesian equation, then you can find the Cartesian equation by the regular method. We can solve the top equation, or the left equation, for t. So we get t equals 4 minus x. And then in the other equation, replace t with 4 minus x. And do the arithmetic. So 3 times 4 is 12 minus 3x plus 2. And we get y equals negative 3x plus 14. Okay, so we verified that we have the right equation in about 3 different ways. Okay, and the next problem, next sheet. From section 10.8. This says, number 1, find the component form AB in angle brackets of the vector whose initial point has the coordinates 5, 2, and the terminal point with coordinates negative 1, negative 3. And then write the vector in terms of vectors I and j. So just as a reminder, the vector I in component form is the vector 1, 0, and the vector j in component form is 0, 1. Those are the component vectors for vectors I and j. Okay, so the component form AB, well, at the terminal point, the x-coordinate is negative 1, so we write negative 1, and then we subtract the x-coordinate of the initial point. And then for the y-coordinate of the terminal point is negative 3, and from that we subtract the y-coordinate of the initial point. So we get the component vector negative 6, negative 5. And then using the unit vectors I and j, we'll write a linear combination. So negative 6, negative 5 is equal to negative 6 times the unit vector I, and then plus negative 5j, but we'll just write minus 5 times the unit vector j. So we say that we refer to this. This is the vector negative 6, negative 5 in component form, written as a linear combination of vectors I and j. Vectors I and j. So We're not going to go into it, but a linear combination of two vectors has a definition for what it means for something to have a linear combination. And if you eventually take linear algebra, you'll learn more about that. It's not a difficult concept, but just keep that in mind. Linear combination involves a definition. Okay, the next one, number 2. Given vectors u in component form has components 2 and -3, and vector v in component form 1, 5. Compute vector u plus vector v, and also 3 times vector u minus 2 times vector v. And then also find a unit vector in the same direction as vector u. Okay, so vector u plus vector v, well, u in component form, 2, -3, we're just adding that to vector v in component form. So we just add the x components, or the first components. 2 plus 1 is 3. And then add the second components. -3 plus 5 is 2. Okay, so that's all there is to that. 3 times the vector u minus 2 times the vector v. So we can write this as 3 times the vector 2, -3 in component form, and then minus 2 times the vector v in component form. Okay, and remember how scalar multiplication works for vectors. We multiply the scalar 3 times each of the components. So 3 times the component vector 2, -3 is the component vector 6, -9. And then we're subtracting 2 times the component vector 1, 5, and that's the component vector 2, 10. And then when we do the subtraction of the component vectors, do the subtraction in the first component. 6 minus 2 is 4 for the first component. The second component, -9 minus 10 is -19. Okay, the unit vector in the same direction as the vector u is found by dividing the vector u by its length. So this is the symbol that represents the unit vector in the direction of u. So the vector u, we'll just put that in the numerator in component form, 2, -3. And over here, let's find the length of vector u over here on the side. So this is going to be equal to the square root of the sum of the components squared. So the square root of 2 squared plus the number -3 squared. And you can see that we're going to, inside the square root, we're going to get 4 plus 9, which is 13. Square root of 13. So in the denominator, we just have the number square root of 13. The length of this vector is 1. That's why it's called a unit vector. So I'll just make a note of that, unit vector, in the direction of the vector u. Okay, the next problem, given vectors U and V, find the dot product. So this means dot product. Okay, so the dot product of vector U and vector V is just the sum of component-wise multiplication. So the component vector for U, -2, 4, we have a dot product with vector V. So the dot product of two vectors is a real number. So -2 times -3. I'll go ahead and write it out a little bit. -2 times -3, and then plus 4 times 1. So we get 6 plus 4, or 10. So 10 is just a real number. That's the result of a dot product, is a real number. Okay, the next example will graph the vectors U and V, which are given in component form. And then we'll show graphically how to find new vectors, vector U plus vector V, and also vector U minus vector V. So I'll probably end up drawing two pictures, one for U plus V and the other one for U minus V. So let's see, 3, 1. Okay. So 3, 1. Okay, so 3, 1 in standard position looks like this. This is the vector U, and vector V is 1, 2 in standard position. Okay, so that's vector U, and this is vector V. So yesterday when we discussed vector addition graphically, we said if we want to add vector U and vector V, we move vector V so that the vector V's initial point is at the endpoint of U. And we know how to graph the direction of vector V. It's horizontally to the right 1 and vertically up 2. So from the endpoint of V, if we just move to the right 1 and up 2, then this is the vector V translated. So my picture doesn't really look like it, but those are supposed to have the same length. And then vector U plus V is represented by this vector. So we connect the initial point of vector U to the endpoint of vector V, and that is U plus V. So if our picture is accurate, it looks like U plus V has a first component of 4 and a second component of 3. And we can verify that just by doing the arithmetic addition of vectors U and V. So U plus V, sure enough, 3 plus 1 is 4, that's the first coordinate, and 1 plus 2 is 3 is the second coordinate. So you can see that it works out geometrically, this, which is equivalent to the arithmetic interpretation. Okay, then we'll also show how graphically to get vector u minus vector v. Okay, so on this one, I think I'll need a little more space below. A little bit. So we'll plot vectors u and v again. So vector v, component 3, 1, and vector v, 1, 2. Okay, so that's vector v. This is vector u. Well, for u minus vector v, we're going to think of it as adding vector u to the vector negative v. So negative v is just in the opposite direction as v with the same magnitude. Okay, so this is the vector negative v in standard form. So it's negative 1, negative 2. Okay, so if we want to add u plus, we're adding u plus negative v, which is u minus v, vector u minus v. We translate vector v so that its initial point is at the end point of u. And so from there, we move down 2 and to the left 1. Okay, so there is vector negative v. So u plus negative v can be found graphically this way. So that vector is vector u minus vector v. And the components are 2 and negative 2. Then we can do the arithmetic to verify that that's true. So vector u minus vector v, the first component, 3 minus 1 is 2. So what did I do? Oh, I misdrew. So see, it's a good thing that we have ways to check our work. I go down 2 and not 3. So I made a bad mistake. So the component of this is 2, negative 1. 2, negative 1. So this is our vector instead, 2, negative 1, and it's a good thing we know how to check using the arithmetic. Okay, so to reiterate, vector u minus v in component form is 2, negative 1. Okay, let's move on to the next page. Hey, so these are some problems from section 9.3. So you'll recognize, hopefully, what formulas we want. 2 times sine of 15 degrees times cosine of 15 degrees. Well, that looks like the double angle formula for sine of 2 theta. Sine of 2 theta is 2 times sine of theta times cosine theta. So if theta is 15 degrees, then 2 theta is 30, and this is just sine of 30 degrees. And that's a special angle. Sine of 30 degrees is 1/2. Okay, so that wasn't too bad. The other one, cosine of 22.5 degrees squared minus sine of 22.5 degrees squared. So we remember the double angle formula for cosine. Cosine of 2 theta is cosine squared of theta minus sine of theta squared. Okay, so if theta is 22.5 degrees, then 2 times theta is 45 degrees. So this is just cosine of 45 degrees. And we know that that's the square root of 2/2, another special angle. Okay, the double angle formula for tangent. Tangent of 2 theta is equal to 2 times tangent of theta divided by 1 minus tangent of theta squared. If theta is 75 degrees, then 2 times 75 is 150 degrees. So this is just tangent of 150 degrees. You can also think of that as sine of 150 degrees divided by cosine of 150 degrees. So 150 degrees is in the second quadrant. Sine of 150 degrees is 1/2. Cosine of 150 is negative. It's the negative square root of 3/2. And if we simplify a little bit more, we get negative 1 over the square root of 3. Okay, from section 9.4, use product to sum formulas to evaluate. Okay, so let's see. This involves sine of alpha plus beta, sine of alpha times cosine of beta plus cosine of alpha times sine of beta, and then sine of alpha minus beta is sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Well, if we subtract, there's more than one way to go about it. We can make it work in a couple of different ways, but if we subtract the bottom equation from the top equation, we get sine of alpha plus beta minus sine of alpha minus beta. And then on top, we get cosine of alpha times sine of beta minus negative cosine of alpha times sine of beta. These terms add up to 0. So that's equal to 2 times cosine of alpha times sine of beta. And then if we divide both sides by 2, we have the formula that we want, cosine of alpha times sine of beta is equal to 1/2 times sine of alpha plus beta minus sine of alpha minus beta. Okay, so if alpha is 135 degrees, so alpha is 135 degrees, and beta is 15 degrees, then we could just use this formula. This will be equal to 1/2 times sine of alpha plus beta, which is 150 degrees, and then minus sine of 135 degrees minus 15 degrees, or which is 120 degrees. And these are all special angles, special enough anyway. Sine of 150 degrees is 1/2. Sine of 120 degrees is the square root of 3/2. So we can write it as 1 minus the square root of 3 all over 4. Okay, then the next one, find cosine of 255 degrees plus cosine of 195 degrees. Well, on this one, I told you before, I never remember these formulas. I have to derive them every time. So let's see, cosine of alpha plus beta. I know these formulas. This is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And then cosine of alpha minus beta. This is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And we want a sum of two cosines. So if we add the two equations, we get cosine of alpha plus beta plus cosine of alpha minus beta. And on the right-hand side, the right terms add up to 0, and we just get 2 times cosine of alpha times cosine of beta. Okay, so this is the formula that we want. We want alpha plus beta to add up to 255. So alpha plus beta is 255 degrees, and alpha minus beta is 195 degrees. When we add these two equations, the betas are eliminated, and we get 2 times alpha equals 450 degrees, which means alpha is 225 degrees. And we can use either of the other two equations to find beta. If we use the top equation, replace alpha with 225 and then subtract 225 on both sides, we get beta equals 30 degrees. Okay, so this will be equal to 2 times cosine of alpha, which we found to be 225 degrees. Sorry, I'm going to multiply that by, I'm not going to add, it's 2 times cosine of alpha times cosine of beta. So this is multiplication cosine of 30 degrees. 225 degrees is in the third quadrant. The special angle, or the reference angle, is 45 degrees. Cosine of 45 is the square root of 3/2, but this will be negative because it's in the third quadrant. So 2 times negative square root of 2/2, and then times cosine of 30, which is the square root of 3 over 2. These twos cancel, so we get negative square root of 6 over 2. Okay, let's move on to the next page. Okay, find the solutions to the equations. Okay, on the interval from 0 to 2 pi. So first, divide both sides by 2. Cosine of 2x is the square root of 3 over 2. And we know two values for 2x between 0 and 2 pi. If 2x is pi over 6, or 30 degrees. And then the other one, if 2x is equal to 11 pi over 6 in the fourth quadrant. But remember, we're solving for x, so x is equal to pi over 12. And the other value of x is 11 pi over 12. Okay, remember what happens. We're going to get two more solutions. If you think of cosine of 2x, the period of cosine of 2x is pi. So to find the other two solutions, we just add pi to each of those two. So pi over 12 plus pi is 13 pi over 12. And then the fourth and final solution is 11 pi over 12 plus pi, which is 23 pi over 12. Okay, so we have four solutions on the interval from 0 to 2 pi on that one. Okay, the next one involves a quadratic equation in form, quadratic in form. So we're going to replace cosine of x squared with 1 minus sine of x squared, so that we have a trigonometric equation that's quadratic in form with one sine function only. So 6 minus 6 times sine of x squared minus 7 times sine of x minus 1. So negative 6 times sine of x squared minus 7 times sine of x plus 5 equals 0. For convenience, I'm just going to multiply both sides by negative 1 to get 6 times sine of x squared plus 7 times sine of x minus 5 equals 0. And then we can factor by grouping. 6 times sine of x squared plus 10 sine of x minus 3 times sine of x minus 5 equals 0. Out of the first two terms, we can factor out 2 sine of x to get inside the parentheses 3 times sine of x plus 5, and then out of the third and fourth terms, factor out negative 1. So we get 3 times sine of x plus 5. And then finally, 2 times sine of x minus 1 times 3 sine of x plus 5 equals 0. Set each factor equal to 0. This equation, we get sine of x equals 1/2. The other one, when we solve that for sine of x, we get sine of x equals -5/3. But sine of x can never be equal to a number smaller than -1, so we get no solution from this one. And then sine of x equals 1/2 has two solutions between 0 and 2 pi. So x is pi over 6 is one of the solutions, and the other one is 5 pi over 6. Okay, the next one, solve the triangle ABC, where angle A is 67 degrees, angle B is 62 degrees, and side C is 200. Okay, if we want to use the law of sines, we can find that angle C has to be 51 degrees. If I did that right, let's see, 129, yeah, 51. So we can use angle C and the length C. We can write 200 over sine of 51 degrees equals a over, lowercase a over sine of 67 degrees. And each of those will be equal to lowercase b over sine of 62 degrees. Okay, if we solve this equation on the left, we get lowercase a equals 200 times sine of 67 degrees over sine of 51 degrees. So this is our answer because we're not using calculators and the angles aren't special angles. Then to solve for b, multiply both sides by sine of 62 degrees, we get b equals 200 times the sine of 62 degrees divided by sine of 51 degrees. Okay, the next one, find the area of triangle ABC where A is 143 degrees, B is 20 inches, and C is 16 inches. Well, what happens if you forget the formula for finding the area? Well, hopefully at the very least, you'll remember that the area of a triangle is 1/2 times the base times the height. So we're given, this doesn't look like 143 degrees, but we're just using it as an aid. Side B is 20 inches. Side C is 16. So we can use the side that's 16 inches long as the base. And then we can construct this height. And then we can use the fact that sine of 143 degrees is equal to the height divided by 20 using this right triangle on the left. So sine of 143 degrees is equal to h over 20. So that means the height is 20 times the sine of 143 degrees. And so the area of that entire big triangle is 1/2 times the base. The base that we're using is 16. So 1/2 times 16 times the height, which is 20 times sine of 143 degrees. Okay, so the formula that you could memorize that would be applicable in this case is the area equals 1/2 times B times C times the sine of angle A. I have the B and C in different orders, but okay, so memorize the formula or just do more basic stuff if you have to. Okay, solve triangle ABC if the three sides are given. A is 28, B is 17, and C is 25. So if we start by trying to find angle A, then we'll use this part of the law of cosines. A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Okay, so A squared, 28 squared equals B squared, which is 17 squared plus C squared minus 2 times 17 times 25 times the cosine of alpha. And then solve for cosine of alpha. And then once you have cosine of alpha equal something, then you can find that A is equal to the inverse cosine of whatever that quantity is. So the algebra and arithmetic is pretty basic, that you should be able to do that. And then if you have to find angles B and C, you would just do the same process. Okay, in the next part, section 10.3, convert from polar coordinates to rectangular coordinates. So R is 3 and theta is pi over 6. So in general, we know that x equals the x-coordinate in rectangular coordinates is r times cosine theta, and y is r times sine of theta. Okay, so the x-coordinate is 3 times cosine of pi over 6. The y-coordinate is 3 times sine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2, so we get 3 times the square root of 3 over 2 for the x-coordinate. And sine of pi over 6 is 1/2. 3 times 1/2 is 3/2. So I suppose we write xy as an ordered pair. The x-coordinate is 3 times the square root of 3 over 2. The y-coordinate is 3/2. Okay, so the same thing over here. X is r times cosine of the angle. Theta is 2 pi over 3. The y-coordinate is -4 times sine of 2 pi over 3. And cosine of 2 pi over 3 in the second quadrant is -1/2. So x is -4 times -1/2 is +2. And in the second quadrant, sine of 2 pi over 3 is positive square root of 3 over 2. So the y-coordinate is -2 times the square root of 3. So the rectangular coordinates, x, y, in parentheses, The x-coordinate is 2, and the y-coordinate negative 2 times the square root of 3. Okay, then in the next exercise, convert from rectangular coordinates to polar coordinates. Okay, this one, this is rectangular coordinates. It's in the 4th quadrant. And so r is just going to be the square root of 4 times the square root of 2, quantity squared, plus the number negative 4 times the square root of 2 squared. So 4 squared is 16, and the square root of 2 squared is 2. And 16 times 2 is 32. And here we get the same number, so we get the square root of 32 plus 32, which is the square root of 64, which is 8. Okay, so the value of r is 8, and tangent of theta is negative 4 times the square root of 2 divided by 4 times the square root of 2, which is negative 1. And so theta is in the 4th quadrant. So the inverse tangent of negative 1 is negative pi over 4. So if we want theta to be between 0 and 2 pi, then we can just add one cycle or one rotation, add 2 pi to negative pi over 4. So we get 7 pi over 4. Okay, so the r theta, r is 8, and the angle is 7 pi over 4. It wouldn't, as you know, it would not be incorrect to use negative pi over 4 because there are infinitely many ways to represent a point using polar coordinates. Well, this next point is also in the 4th quadrant. So this time r is the square root of 2 squared plus the number negative 2 times the square root of 3 squared. So 2 squared is 4, and then when we square negative 2 times the square root of 3, we get 12. And then the square root of 16 is 4. So the value of r is 4. Tangent of theta is negative 2 times the square root of 3 over 2, or negative square root of 3. So the inverse tangent of negative square root of 3 is negative pi over 3. So we could write the polar coordinates r theta as 4 for the r value and negative pi over 3 for the theta value. But if you want to add 2 pi to negative pi over 3, you can write theta as 5 pi over 3. But either one is okay. Okay, the next page, let's graph this sine function, y equals 2 times sine of pi over 4x minus pi over 2. So I prefer, for one period, well, the pi over 4 times x minus pi over 2 has to range between 0 and 2 pi. So I'm going to write a compound inequality between 0 and 2 pi. And then I'm going to solve for x. So first thing, we'll add pi over 2 to all three parts. So we get pi over 2 is less than or equal to pi over 4 times x, which is less than or equal to 5 pi over 2. And then we'll multiply all three parts by the reciprocal of pi over 4. So when you multiply this by the reciprocal, in other words, multiply by 4 over pi, this is going to become 2. The middle part becomes x because a non-zero number multiplied by its reciprocal is 1. And then multiply 5 pi over 2 by 4 over pi, we get 10. So the period of this is 8 from 2 to 10, and I'm going to graph this function on that interval from 2 to 10. The amplitude is 2. The center line is y equals 0. There's no vertical shift. Okay, so on the interval from 2 to 10, my key points are determined by subdividing that period from 2 to 10 into 4 intervals. So I'll go ahead and sketch what I believe the graph is going to look like, and then we can verify afterwards that it's correct. So this is what I believe the graph is going to look like, at least as best as I can graph it. Okay, but we will verify by picking a few x values like 2, 4, 6, 8, and 10. Okay, so when x is 2, pi over 4 times 2 is pi over 2. Pi over 2 minus pi over 2 is 0. Sine of 0 is 0. 2 times 0 is 0. Okay, so that agrees with what I've graphed. This is the ordered pair 2, 0. When x is 4, pi over 4 times 4 is pi. Pi minus pi over 2 is pi over 2. Sine of pi over 2 is 1. 2 times 1 is 2. And so the ordered pair 4, 2 is on the graph. And you get the idea. I'll leave the rest of those for you to verify. But I'm quite certain that this will be 6, 0. Replace x with 6 and do the arithmetic. And then replace x with 8. I guess we can do this one. When x is 8, pi over 4 times 8 is 2 pi. 2 pi minus pi over 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1, and 2 times negative 1 is negative 2. So we have this point, 8, negative 2. And then lastly, when x is 10, we're going to get a sine value that's 0. So we can label this point 10, 0. Okay, if you have a problem like this on the final, then this is all you would have to do. Just verify that things work out. Okay, let's graph the cosine function. Well, the period of this one is 2 pi. My argument, x minus pi over 2, I need that to be between 0 and 2 pi. So 0 is less than or equal to x minus pi over 2, which is less than or equal to 2 pi. And then we're going to solve the compound inequality for x. So we add pi over 2 to all three parts. Pi over 2 is less than or equal to x, which is less than or equal to 5 pi over 2. Okay, so the interval that I'm going to sketch the graph of is from pi over 2 to 5 pi over 2. The amplitude is 1. Yeah, so if this is pi over 2, if I'm dividing an interval of length 2 pi into 4 equal parts, then each subinterval is 2 pi divided by 4, or pi over 2. So each of these subintervals is of length pi over 2. Okay, the amplitude is 1. So I'm expecting this to be a point on the graph when x is pi over 2, y is 1. When x is pi, y is 0. When x is 3 pi over 2, I am expecting y to be negative 1. At 2 pi, the y value is 0, and at 5 pi over 2, the y value is 1. So I get one period of cosine, looking something like this. So once again, we can verify that these are the right points. So I'll pick x values pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Okay, first, when x is pi over 2, replace x with pi over 2. Pi over 2 minus pi over 2 is 0. Cosine of 0 is 1. So the y-coordinate should be 1. And that's what we have. When x is pi over 2, the y-coordinate is 1. Okay, when x is pi, we have cosine of pi minus pi over 2. Pi minus pi over 2 is pi over 2, and cosine of pi over 2 is 0. So the y-coordinate is 0 there, and that's what we have on the graph. Pi is 0. For 3 pi over 2, for x, 3 pi over 2 minus pi over 2 is pi. Cosine of pi is negative 1, and that's what we get on the graph. The x-coordinate, 3 pi over 2, the y-coordinate, negative 1. And so on. When x is 2 pi minus pi over 2 is 3 pi over 2. The cosine of that is 0, so we get 2 pi 0. And then lastly, when x is 5 pi over 2, 5 pi over 2 minus pi over 2 is 2 pi. Cosine of 2 pi is 1. So we get this ordered pair of 5 pi over 2, comma 1. Okay, the next page. Let's graph a tangent function. So for y equals tangent of x, the period of tangent is pi. And for tangent of pi over 2x plus pi, we need that to be between negative pi over 2 and positive pi over 2. So we'll solve this for x. We'll subtract pi from both sides. And so this becomes negative 3 pi over 2 less than pi over 2x. And pi over 2 minus pi is negative pi over 2. And then we're going to multiply all three parts by the reciprocal of pi over 2. So in other words, multiply by 2 over pi. So 2 over pi times negative 3 pi over 2 is going to be negative 3. And in the middle, we get x when we multiply by the reciprocal of pi over 2. And then negative pi over 2 times 2 over pi is negative 1. So the period of this tangent function is going to be between negative 3 and negative 1. And negative 3 and negative 1 is where we have the vertical asymptotes. Okay, so here's the x-axis, and then negative 1, negative 2, negative 3. So we have vertical asymptotes. We also want to find 3 key points. So we also divide this interval into 4 parts. So this point will be negative 3 halves, and then halfway between negative 3 and negative 2 is negative 5 halves. Okay, so our 3 key points involve x values of negative 5 over 2, negative 2, and negative 3 over 2. And then it's also the vertical asymptotes also have to be identified. Okay, so we'll find the 3 key points using x values negative 5 over 2, negative 2, and negative 3 over 2. And then label the vertical asymptotes, x equals negative 3, x equals negative 1. Okay, then when x is negative 5 over 2, we get pi over 2 times negative 5 over 2 is negative 5 pi over 4, and negative 5 pi over 4 plus pi is negative pi over 4, and the tangent of negative pi over 4 is negative 1. Okay, so if this is negative 1, then we have this point on the graph, negative 5 halves, negative 1. When x is negative 2, pi over 2 times negative 2 is negative pi. Negative pi plus pi is 0, and tangent of 0 is 0. So the y-coordinate is 0. So we have this point, negative 2, 0. When x is negative 3 over 2, pi over 2 times negative 3 over 2 is negative 3 over 4. So I should say negative 3 pi over 4. And negative 3 pi over 4 plus pi is pi over 4. And tangent of pi over 4 is 1. So the y-coordinate is 1 on this one. Okay, so when x is negative 3 over 2, the y-coordinate is 1. And then do the sketch of the graph. It's a rough sketch. Okay, the cotangent This will be similar to graphing tangent, similar in that the period of y equals cotangent of x is pi. The interval, though, that we pick will be different than tangent. On this one, we need 1/3 x minus pi to be between 0 and pi. So 0 is less than 1/3 x minus pi, which is less than pi. So now we solve for x. We add pi to all three parts, and we get pi is less than 1/3 x, which is less than 2 pi. And then multiply all three parts by 3. We get 3 pi is less than x, which is less than 6 pi. Okay, so the interval that we'll sketch the graph on is from 3 pi to 6 pi. So 3 pi to 6 pi. We will have vertical asymptotes there. So one vertical asymptote is x equals 3 pi, and the other one is x equals 6 pi. Okay, well, we want to divide the interval from 3 pi to 6 pi into 4 parts. So the middle one is 9 pi over 2, 4.5 pi. And this one on the left, that's going to be 3 pi plus 3 pi over 4, which is 15 pi over 4. Kind of awkward, but... And then this part will be 9 pi over 2 plus 3 pi over 4. Which is 21 pi over 4. So the 3 key points will have x values at each of those. So you can create a table for the 3 key points. 15 pi over 4, 9 pi over 2, and 21 pi over 4. So let's try this one. When x is 15 pi over 4, 1/3 of that is 5 pi over 4. And 5 pi over 4, 5 pi over 4 minus pi is pi over 4. And cotangent of pi over 4 is 1. So we plot that point. So the x-coordinate 15 pi over 4, the y-coordinate is 1. So if you know anything about graphing cotangent functions, that's a good sign. Okay, when x is 9 pi over 2, 1/3 of 9 pi over 2 is 3 pi over 2. 3 pi over 2 minus pi is pi over 2. Cotangent of pi over 2 is 0. So this is a point on the graph, 9 pi over 2, 0. One of the 3 key points. And one more, when x is 21 pi over 4, 1/3 of 21 pi over 4 is 7 pi over 4. 7 pi over 4 minus pi is 3 pi over 4. And cotangent of 3 pi over 4 is negative 1. So negative 1 at that point. So that ordered pair is 21 pi over 4, negative 1. And then the graph of the cotangent looks something like that. Okay, let's move on to the next page. Okay, find the values. The arc cosine of square root of 3 over 2, or the inverse cosine of square root of 3 over 2 is pi over 3, or 60 degrees. The cosine of arc sine of 1/4, well, on this one we can use a right triangle. So we want to find the cosine of theta. If theta is arc sine of 1/4, then the sine of that is 1/4. And then using the Pythagorean theorem, we get that this is the square root of 15. So the cosine of that angle is the square root of 15 over 4. Find the exact value. The inverse cosine of sine of 11 pi over 4. So find sine of 11 pi over 4. Well, 11 pi over 4 is bigger than 2 pi, so you can subtract 2 pi or 8 pi over 4, and you get 3 pi over 4. So this should be equal to the inverse cosine of sine of 3 pi over 4. Sine of 3 pi over 4, that's in the second quadrant. So this is the angle whose cosine is the square root of 2 over 2. And the inverse cosine of the square root of 2 over 2 is pi over 4. Okay, find the exact value of inverse tangent of cosine of pi. Cosine of pi is negative 1. And remember what the range of inverse tangent is. It's between negative pi over 2 and pi over 2. So the inverse tangent of negative 1 is negative pi over 4. Okay, the next page. Well, if the Washington Monument is 550 feet tall, 555 feet, and the angle of elevation from a shadow is what we want to find. So if the shadow is 620 feet, the angle of elevation is formed by the horizontal and the slanted line from the point to the top. So it looks like the easiest thing is to first write tangent of theta is 555 over 620. And so the theta is inverse, the inverse tangent of that number, 555 over 620. That's a good enough answer. Okay, next page. Verify the identity. Well, if you begin on the right and replace secant of x with 1 over cosine of x, replace tangent of x with sine of x over cosine of x, and we're squaring this, then this is 1 minus sine of x over cosine of x squared. And then if we just write the numerator as the quantity 1 minus sine of x squared, and the denominator as cosine of x squared. Then replace cosine of x squared in the denominator with 1 minus sine of x squared. And then the denominator is a difference of squares, so we get 1 minus sine of x squared, quantity squared in the numerator. And then we factor 1 minus sine of x squared, we get 1 minus sine of x times 1 plus sine of x. And then one factor of 1 minus sine of x cancels from both the numerator and denominator, so we get 1 minus sine of x in the numerator and 1 plus sine of x in the denominator. For this one, start on the left-hand side and then replace 1 with 1 plus cosine of x over 1 plus cosine of x using the common denominator. And then we probably want to replace sine of x squared in this numerator with 1 minus cosine of x squared. And now that we have a common denominator, 1 plus cosine of x. So in the numerator, 1 plus cosine of x minus, we have to subtract the entire numerator. So 1 minus 1 is 0. And we have cosine of x minus negative cosine of x squared, which is plus cosine of x squared. And then factor cosine of x out of both terms in the numerator. Cosine of x times the quantity 1 plus cosine of x divided by 1 plus cosine of x. And the 1 plus cosine of x factors cancel. We're just left with cosine of x. Okay, on the next one, find the exact values. Cosine of 15 degrees. Remember the half-angle formulas. Cosine of alpha over 2. The half-angle formula is plus or minus the square root of 1 plus cosine of alpha over 2. We know that cosine of 15 degrees has to be positive, so we'll take the positive square root, and it will be the positive square root of 1 plus cosine of 30 degrees over 2. 15 degrees is the half angle of 30. And we can take this further because we know what cosine of 30 is. Cosine of 30 is the square root of 3 over 2. So if you have something like this on the final, this is an okay answer. Just leave it in that form. Okay, we recognize this. This looks like the sine of alpha plus beta formula. So this is like sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So this should just be equal to sine of 25 degrees plus 35 degrees, or the sine of 60 degrees, which is the square root of 3 over 2. And we also recognize this as coming from the formula cosine of alpha plus beta. So alpha is 99 and beta is 36. So this is the cosine of 99 degrees plus 36 degrees, which is the cosine of 135 degrees. So the reference angle is 45 degrees. It's in the second quadrant, so cosine is negative there, so it's negative square root of 2 over 2. Find the exact value tangent of 150 degrees. There's, as usual, a number of ways to do it. You can think of this as sine of 150 degrees divided by cosine of 150 degrees. Sine of 150 degrees is 1/2. Cosine of 150 degrees is negative square root of 3 over 2. So this is negative 1 over the square root of 3. Okay, the next page. Find the reference angles. So negative 3 pi over 4 counterclockwise, and then the reference angle is pi over 4. 285 degrees is counterclockwise. This one over here is clockwise. This one's counterclockwise. Here we're at 270, so we go 15 degrees more. And so the reference angle is 75 degrees. 4 pi over 5, that's in the second quadrant. So we go something like this, and the reference angle is pi over 5. Okay, given a central angle theta and radius r, find the arc length and sector area. Okay, so the area is 1/2 r squared times theta. So 1/2 times 14 squared times theta. And you could do the arithmetic on that. And then the arc length. Arc length is just r times theta. So 14 times pi over 7. So if you include the units for area, that's square inches, and arc length is just in inches. So we're down to less than 5 minutes. You can do the other one, just using the same formulas for arc length and area, sector area. Let's see. I guess we can do this one. One acute angle in a right triangle measures pi over 12 radians, and the shortest side is 18 inches. Find the length of the other two sides. Okay, well, if it's a right triangle, the two acute angles have to add up to pi over 2. So pi over 12 has to be the smaller angle. And the other angle has to be 5 pi over 12 because they have to add up to pi over 2. So the shortest side is opposite of the smallest angle. So how do we find the other two sides? Well, sine of pi over 12 is 18 over h. So we can determine what h is if we divide 18 by sine of pi over 12. That's one way to do it. And then we could use tangent of pi over 12. which is 18 over a, so that a is equal to 18 divided by tangent of pi over 12. Okay, we're down to less than 1 minute. I think you know how to do these other problems. So let's do this one until time runs out. Identify the ordered pair on the unit circle that corresponds to the real number t equals 7 pi over 4. 7 pi over 4 is in the fourth quadrant. The reference angle is pi over 4. But that's more detail than is necessary. We can just write x equals cosine of 7 pi over 4 and y equals sine of 7 pi over 4. So the x coordinate is positive in the fourth quadrant. It's the square root of 2 over 2. The y coordinate is negative in the fourth quadrant, negative square root of 2 over 2. So the ordered pair, square root of 2 over 2 for x and negative square root of 2 over 2 for y. Okay, we're out of time. We'll have the final exam tomorrow starting at 11 a.m. You can start a little bit earlier if you want. I'll send information about the Zoom meeting for the final a little bit later today, but that's all for today.